Okay, now we are going to begin module 7, and here we'll be talking about confidence interval. So here we'll be using the concept from module 6. We'll be using all those normal distribution. We'll also be using the sampling distribution, okay, for the mean and also the proportion to create the confidence interval. But before we, start working on the fundamental terms related to confidence interval, I want to give you an example of confidence interval. Say, for example, I want to find the average age of students in a class. Okay, I want to find average age of students taking a particular class, let's say in Colorado, the whole state. So if I want to do that, I will not be able to ask every single student in this state what their age are or what their age is and then find the average, right? That is kind of impossible. I'll not be able to go to every single student. Say, for example, I'm interested in finding the average age of students taking statistics, okay? What I can do is instead, I can collect a sample of few students, maybe 50 or 60 students, right? Maybe I can take this class and maybe another class that I teach, both statistics, right? Or maybe I can collect one group of students from here and one from some other college and then find the average age of these students. Say, for example, the average age of the sample is 25 years. Okay, assume that the average age from my sample is 25 years. So what will be the average age of everyone taking this class in the state? It can be a little bit more than 25 or a little bit less than 25, right? And we'll be able to say that with certain confidence. If I say 25 plus or minus 2, if I write like that, 25 plus or minus 2, what I'm saying is 25 minus 2 means 23, right? And 25 plus 2 is 27. So I'm saying that the average is from 23 up to 27. I'm giving an interval, right? So that is where the interval comes from. And the confidence, how much confidence you are? Are you 95% sure or 99% sure? You'll also mention that. If I say that the average age of a student is from 23 up to 27 or 25 plus or minus 2 with 90% confidence, then I'm giving you the 90% confidence interval. Okay, so confidence referred to the confidence label, how much confident you are with your result. Okay, whether it is 95% true or 99% true or how much is that? That is what we are looking here. Okay, we'll have some sample and from that sample we'll form the confidence interval. Basically, in our course for this intro class, we'll find the confidence interval for the mean or confidence interval for the proportion. And we should be able to, give this confidence at certain confidence label. And most commonly used confidence label are 90% confidence label, 95% confidence level, and 99% confidence level. Out of these three, if I go 90% confidence, then there are 10% chances that I am wrong, right? 90% true, 10% wrong. If I go 95%, then I'm 95% true, but there are chances still that 5% I may be wrong. So higher the confidence level, better the result is. Okay, and out of these three, most widely used confidence label is 95%. It is sometimes really difficult to get that 99% result. So we stick around 95%, okay, in the real scenario. But for you in the test or in the quiz, in the question, it will be mentioned what confidence label we want. That will be stated in the problem. And based on that, you'll solve it, okay? So let's look at some basic terms related to confidence interval. This is where we are going to begin. The first one we want to learn here is the point estimate. Because as I talk about the confidence interval, say, for example, I may be constructing an interval and I found that some value in the middle, like I was talking about 25, that goes in the middle, and then the actual value may be a little bit less than that and a little bit more than that. So this is our confidence interval. This is confidence interval. Confidence. And the value that goes in the middle, okay, the value that goes in the middle, that's called the point estimate. Point estimate is the value that goes in the middle. You can see point estimate is specific numerical value estimate of the parameter. We are estimating the parameter, or we are estimating the population with the value that goes in the middle. If we are talking about mean, then the sample mean will go in the middle. If we are talking about proportion, then sample proportion will go in the middle. Okay, the best point estimate of the population mean mu is the sample mean, and for the population proportion is the sample proportion. So one more time, when you're constructing the confidence interval, the value that goes in the middle, this is called the point estimate. This is called the point estimate. And this is the value from the sample. This is the value from sample. So it is like sample mean or sample proportion. Sample mean or sample proportion goes in the middle. Now what we do is, once we figure out the value that goes in the middle, which is also called the point estimate, we have to find the boundary so that the interval is produced, right? So after that, what we do is we find the lower boundary, we find the upper boundary, and we get the interval. And in this interval, we have the range of values from the lower value up to the upper value. And that interval that estimates the population parameter, that is called the interval estimate. So the definition for interval estimate is the interval estimate of parameter is the interval or range of values used to estimate the parameter. Okay, this estimate may or may not contain the value of the parameter being estimated. Sometimes what happens is, when we try to construct the confidence interval, we are, making this interval with certain confidence, right? We are true with that confidence level. 95%, we are 95% sure. But 5%, we may not be there, right? So it's like 5% of the values may not belong to that interval. If we go back to the example of the age of students, 25 in the middle, right? And I said 23 up to 27. Some students may be more than 27, and some students may be less than 23, right? If I'm 95% sure, then 5% of the student may be outside that boundary. Okay, that is something you need to remember. So statistics will not be able to give you 100% exact result, but it will give you the result with certain confidence. Okay, so we'll be able to tell with certain confidence that the value lies between these two. And that is called the interval estimate there, the range of values. So one more time, confidence interval now. You have the basic idea about this now. Confidence label is the next term we want to learn. Confidence label of an interval estimate of a parameter is the probability that the interval estimate will contain the parameter, right? In that example of 25 plus or minus 2, for example, I'm 95% sure that the age lies in that. So the probability that the student age is between 23 and 27 is 0.95. What is the probability that they don't belong to that? 0.05, right? So confidence interval or confidence label of an interval estimate of parameter is the probability that the interval estimate will contain the parameter, assuming that large number of samples are selected and the estimation process on the sample parameter is repeated. So what is the meaning of that is just like in the sampling distribution that you have seen in unit 6, when you pull the samples from the population, you are not just drawing 1 or 2 samples. You are drawing infinitely many samples and you are repeating the process, okay? So that your confidence interval will contain the average. And talking about the confidence interval, let's now finally draw the confidence interval here. How is this interval? Confidence interval. What we have is in confidence interval, what goes in the middle first of all? Point estimate goes in the middle, okay? Point estimate goes in the middle, and then we find the lower and upper boundary. So basically what we'll do is we'll try to find the lower boundary by subtracting a number called margin of error, and upper boundary by adding a number called margin of error. So what we do is point estimate, okay, point estimate minus margin of error, that will give you the lower boundary. Point estimate plus margin of error, that will give you the upper boundary. And in order to find that margin of error, we need the confidence label. As I was talking before, we have some commonly used confidence label are 90%, 95%, and 99%. But we can use any other confidence label, okay? And our calculator can handle all different confidence label for us, okay? So we'll be using our confidence label and certain normal distribution concept that we have done in previous chapter to find that margin of error. So one more time, your confidence interval will look like this. Whenever you are asked to find the confidence interval, what you have to do is you have to find what is the point estimate, what goes in the middle, okay? And then you have to find the lower boundary and upper boundary. But you can see that in order to find the lower boundary or upper boundary, we need the margin of error, okay? And we can find the margin of error. There are ways to find the margin of error. We can find the margin of error using the confidence label that is given to us. So here we have some crazy looking formulas that we want to see. First, let's look at the confidence interval for mean when the population standard deviation is known. Just like in the central limit theorem, we are looking at the confidence interval for three different cases. The first one, confidence interval for mean when the population standard deviation is known. So what happened here is, let's draw the confidence interval again. So because we are talking about the confidence interval for mean, what goes in the middle now? Sample mean, right? Sample mean. The point estimate will be sample mean this time because we are talking about the confidence interval for mean. So sample mean goes in the middle, okay? And then what you have to do is, from the sample mean, you have to subtract the margin of error, or you have to add the margin of error to find the lower and upper boundary for the interval. To find the lower and upper boundary, we have to subtract or add the margin of error. But how do we calculate the margin of error? Here is the easy way that you need to remember. Margin of error, okay, margin of error is equal to, when population standard deviation is known, listen, this is very important. When population standard deviation is known, the distribution will be Z distribution or normal distribution, okay? So we have Z critical times the standard error. Z critical times the standard error. Okay, margin of error is equal to Z critical times standard error. But remember, this standard error, if you remember from chapter 6, standard error is sigma over square root of n, right? So this formula is same as this one here. Margin of error is equal to Z critical times sigma over square root of n. Same formula written differently. So here you can see margin of error equal to that, margin of error equal to this one, margin of error equal to 1, I have written just now. All these three are the equivalent form. But how do we find that Z critical? That is really important here. Okay, because we are talking about Z critical. What is Z critical? How do we find Z critical? That is very important. So we can find Z critical from the normal distribution. So we draw the normal distribution. In fact, we draw the standard normal distribution because we have Z value there, right? So let's kind of draw one just to represent this. So we can draw a standard normal distribution. When I say standard normal distribution, it's a normal distribution with mean 0 and standard deviation 1. 0 goes in the middle and Z along the x-axis. Okay. And then based on our confidence label, whatever confidence level is given in the problem. If the confidence level is 90%, we want to find the values inside the interval, and that should be 90%, right? 90% inside the interval, the rest will be outside. So meaning of that is we try to show the area. We try to show the area over here, which is equal to the confidence level C. This area is C. It can be, if it is 90% confidence level, that area is 0.9. Okay, that area is 0.9. If it's 95% confidence level, then that area is 0.95, and so on. If it is 99%, then this area is 0.99. The remaining area will be distributed on two tails. So the area on the tail, see, the area on two tail is equal to, now see, look at the board. If this area, everybody look at the board. If this area is 90% area, what is the remaining area? 10% divided by 2, right? 10% divided by 2, that's 5% each. So that's why what we do is, we basically do this. Area in the middle, we call it, you have already seen, area in the middle is C. Do you see that? Area in the middle is C. Okay? And the area on the tail is alpha. Area on the tail is alpha. That's equal to 1. We write like this. C plus alpha equal to 1. C is the confidence level. Alpha is the significance level. They also have their name. So C is the confidence level. C is confidence level. And alpha is the significance level. Alpha is the significance level. In this chapter, in chapter 7, we'll be using confidence level a lot. Okay, we'll be talking about confidence level a lot. And in chapter 8, we'll talk more about significance level. But remember, confidence level, that is the area in the middle. Significance level, that is the area on the tail. One more time, if I go back to my example before, if this is 90%, remaining area is 10%, that is divided into two parts, right? So 10 divided by 2. Similarly, if this total area is alpha, then the area on each tail is alpha divided by 2. So we can write that area as alpha divided by 2. Alpha divided by 2. And then, if I want to find this value on the x-axis, let me show you with a dot there, red dot. That value there, that is our critical, Z critical. We write that value, Z critical, Z sub C. Okay? If I use this C in the middle, then that is Z sub C. If I want to represent using alpha over 2, I can also write Z sub alpha over 2. They are the same thing. Okay? Same value. This will be positive. By symmetry, the value on the other side will be negative of that. So the value on the other side will be negative of that critical value. And you know, if you want to find these values, Z critical or negative of that one, okay, what you know is, because you are calculating the value along the x-axis, you have to use inverse normal in our calculator, okay? Because we are calculating the value along the x-axis. We need this Z sub C, Z critical, right? Z critical is required. So in order to find Z critical, we have to use inverse normal. So remember, that's how we find the margin of error. So that is the formula for margin of error. That is the most general formula. The one I boxed is most general. And then when we write Z critical using Z sub C or Z alpha over 2, and then write the value of standard error as sigma over square root of n, you got those two formulas which are above this box here, right? Okay, so one more time, if we can calculate that much, we can easily get the confidence interval. So what we need to do in order to find the confidence interval? First, problem will be given to you, read the problem, right? And then find the information about the sample. Are you calculating the confidence interval for mean or confidence interval for proportion? That is something you need to know first. Okay. If the question is about the calculation of the confidence interval for mean, then sample mean goes in the middle. Sample mean goes in the middle, right? And then to form the confidence interval, we add and subtract the margin of error. We add and subtract the margin of error. Now, in order to find this margin of error, okay, in order to find the margin of error, you have to check whether the population standard deviation is given or not. If population standard deviation is given, then the formula for margin of error is Z critical times standard error. If population standard deviation is not given, it will be something different. And we are going to look that in our second part. Okay, in the first part, it's only when the population standard deviation is given. Now, so this is the case of calculating the confidence interval. Sometimes what they will do is they will ask you to find the sample size for estimating the confidence interval. Okay, so if we do a little bit of math on these equations, we get the formula to find the sample size, which is already given here for you. You don't need to know that calculation, but you just need to know that formula. You can see N is equal to Z alpha over 2 or Z critical times you have a sigma divided by margin of error squared. So if I want to find the sample size, okay, we can use this formula. Z critical, because Z alpha over 2 is same as Z critical, times sigma over margin of error squared. And then remember, if you get a decimal value here, N is the population size, numbers cannot be decimal, right? If I count the number of objects in a sample, it cannot be decimal. So what you have to do is, if I find 50.1, then it's telling you that the sample size is more than 50. So the next number will be 51. So we always round up, whatever it may be, okay? It's not the general rounding here. We are calculating the size, so we always round it up. So that is the basic idea about the confidence interval. So with this basic idea, we'll be able to work on the confidence interval problem. So let's go to the first example in our notes. That will be mentioned in the problem. Yeah, confidence label will be given in the problem. So based on that, we can construct the confidence interval. Okay, here is our first example. Let's read through the problem, try to understand the problem, also understand the process of calculating that confidence interval. Okay, the age when smokers first start from previous studies is normally distributed with a population standard deviation of 1.8 years old. A survey of a smoker of this generation was done to estimate the mean age. The sample of 35 smokers found that their mean starting age was 14.7 years. We have to find the 95% confidence interval for the mean. So here we want to find the average age when someone started smoking for the first time, right? That's what we are trying to do here. But the information that they have given is in general about the population of the smokers. It is found that the population is normal and the standard deviation is given. Do you see that? So standard deviation is known, just like in our first case, standard deviation is known. So you can see it's a normally distributed population with a standard deviation of 1.8 years old. So population standard deviation is given. We want to estimate, we want to find the 95% confidence interval for the starting age of the smokers here, right? And for that, what is done is they are analyzing a sample of 35 smokers. So 35 smokers were asked when they started smoking. Okay, 35. N equal to 35. Found that. So when you ask these 35 people, their average age was how much? 14.7 years old. Sample mean was 14.7. So at that age, they started smoking. 14.7. Right? So probably if we have someone at the age of 14 at our house, we have to be careful if you don't want them to smoke, right? You may check on them. Get into their backpack, right? And find out if they have already started. Take it out. Okay. So that's the value that goes in the middle. So what this data is telling us is the average starting age can be 14.7. Maybe it will be a little bit less than that or a little bit more than that, right? So we want to find that 95% confidence interval. So what we do is we draw that interval. Let's draw the interval. We draw the interval and we know that sample mean goes in the middle. This side, the lower boundary is sample mean minus margin of error. And upper boundary is sample mean plus margin of error. Is that right? Okay. What is the value that goes in the middle? 14.7. We have that value already, 14.7. Now what we need is, if we have the margin of error, then I can easily add or subtract the margin of error, right? We can easily do that. Now let's try to find the margin of error if it is possible. Now the margin of error is equal to Z critical times sigma over square root of n, right? Margin of error is Z critical. Why Z critical? Because the population standard deviation is given. If population standard deviation is given, the distribution will be standard normal distribution, so Z critical. Okay? And then population standard deviation is already given. This is the standard error, which is sigma over square root of n. So this one is already given, 1.8. And square root of n is 35. So we have all information except Z critical. So first of all, we have to find the Z critical. Okay? We'll do the work here on the side and find that Z critical. So in order to find Z critical, we have to draw the normal distribution. Let's draw the normal distribution. Okay, this is our standard normal distribution. Normal distribution with mean 0 and standard deviation 1, because we are talking about the Z values. 0 goes in the middle. Okay, what is the confidence level here? 95. That means area in the middle should be 95%. Okay, we have to show 95% area in the middle. So let's do that. So this area that goes in the middle is 95%. This is 95% or 0.95. What is the remaining area? 5%. 5% is divided on two parts. 5 divided by 2 is how many percent? 2.5%. So that is 0.025, right? 0.025. And that one is also 0.025. And what we are looking for is Z critical. That one. The value which is here is Z critical, right? Okay. Now we want to find Z critical. So let's do that. Z critical is equal to, how do we find the value along the x-axis, like x or Z value? Do you use normal CDF or inverse normal? Inverse normal. Okay. Inverse normal. Inverse normal. Then we need, if you remember, we need area to the left of that, right? Look at the board, everybody. We want to find Z critical. We use inverse normal. Here we need the area. That area must be area to the left of that. Area on the right is 2.5%. That means area on the left is 97.5%, right? 95 plus 2.5, 97.5%. 0.975. 0.975. That's what we write there. Mean is 0, standard deviation is 1. So you can use your calculator now and tell me what is the value of Z critical here. .96. Okay, very good. 1.96. And you know why we are calculating this, right? We are calculating this in order to calculate the margin of error, because in the formula for the margin of error, we need that Z critical, right? So that's why we are doing that. So everybody make sure you use your calculator and check whether you get that 1.96 or not. You're using inverse normal. Okay. Okay, so once you get that value, now let's find the margin of error by plugging in the values in this formula. Z critical, we got 1.96 multiplied 2. Sigma is 1.8 standard deviation, right? Divided by square root of 35. Everybody, please type that information in your calculator and tell me what you'll get. Give me the value up to 4 decimal places. 1.96 times 1.8, divide that by square root of 35. .5963, perfect. 0.5963. Make sure everybody check that, because you must know how to use the calculator and find that value. Okay, once we get that value, the margin of error, let's find the lower and upper boundary for the confidence interval. So lower boundary, let's do that. I'll write LB for lower boundary, which is mean minus the margin of error. Right? The lower boundary is mean minus the margin of error. We are looking at the value on the left. And the mean in the middle, 14.7. Let's do it. 14.7 minus, because the age is given up to, the value in the middle is given up to 1 decimal place. We can also go up to 1 decimal place there. So the margin of error up to 1 decimal place will be 0.6. Is that right? 0.6. So what is that equal to? Please calculate that. 14.1, right? 14.1. And then the upper boundary will be mean plus margin of error. Mean is 14.7, then plus 0.6 when you go to 1 decimal place. What is that equal to? 15.3. So the lower boundary we got is 14.1 and the upper boundary is 15.3. So from all this, we can say the confidence interval. We can say that the confidence interval for the mean is from 14.1 up to 15.3. Make sense? Confidence interval for the mean is 14.1 up to 15.3. So according to this study, what we can say is the average age, okay, for the smokers to start is from 14.1 up to 15.3. So that is the prime age, right? According to this study. So we can write the interval. We can write the interval like this, 14.1 up to 15.3. This is one way of writing the interval by using this parenthesis and putting the lower number and upper number. The other number, or the other way of writing the confidence interval is the way I was telling you before. When I was talking about that age example, I said 25 plus or minus 2. Remember that? So we can also write in that format. Okay. So this is one way. The other way is we can also write this as we have 14.7 in the middle, then plus or minus 0.6. Is that right? We are adding or we are subtracting 0.6. See, we are adding 0.6 here. We are subtracting 0.6 there from the value in the middle. So we can write 14.7 plus or minus 0.6. That's another way of writing. Also, there is a third way of writing this that you need to remember. The other one is, what is this one? This value is the average age of the population, right? In general, this is the age that they start smoking. So that average population mean lies between these two values. So we can write it like this. We can write this as 14.1 less than mu is less than 15.3. So three different ways. Okay, three different ways of writing. So when you're doing your homework, if you see the interval with the parenthesis, then we are asked to write the answer in the first form. Okay. If you see plus or minus, two box with plus or minus in the middle, you are asked to write in the second form. And then if you see the inequality like this, then they are asking you to write the confidence interval in the third form. And sometimes you are asked to interpret the result. We did the calculation, right? We got the result, but what is the meaning of this? You have to interpret the result. What we can say is the meaning of this one is with 95% confidence, we can say that the average age of a smoker when they start for the first time is between 14.1 and 15.3. Does that make sense? So that is the interpretation. So let's also do the interpretation. With 95% confidence, we can say that the average starting age of the smokers when they first start is between 14.1 year and 15.3 years. That is the meaning of that. So you can clearly see in this first example, what we did is we look at the case where the population standard deviation was given. Okay. Remember, when the population standard deviation is given, the distribution is a standard normal distribution. That's why while calculating the margin of error, we use Z critical because of the standard normal distribution. Z critical times sigma over square root of n. So there are two other cases that we want to check in our next class. But for today, we have one more example. Yes, we can do one more example. And this is based on the calculation of the sample size. This one here. See, we have seen here, in order to calculate the sample size, we use n equal to Z critical times sigma over the margin of error. We have seen that. And here is the example based on that. So let's quickly look at this example and find out how we can do it. Okay, you are interested in estimating the mean age of citizen living in your community. We are looking for the mean age there, okay, in the community. In order to do this, you plan to construct a confidence interval. However, you are not sure how many citizens should be included in the sample. So you don't know the sample size, meaning you want to find the sample size here, okay? If you want the sample estimate to be within 4 years, when we say sample estimate within 4 years, that means from the mean, from the average, you can go 4 up and 4 down. That means that is the margin of error, okay? 4 is the margin of error of the actual mean with 96% confidence level. So you have to find how many citizens should be included in this sample. Assume that the standard deviation of all citizens, meaning of that is the population standard deviation, is 25. So we have to label all this first. Let's do it. Whatever information is given. So they have given the margin of error. Within 4 years means that is margin of error. Okay. Confidence level is given. You have to find how many citizens should be included. And the standard deviation of all ages is given. Standard deviation is 25. That information is given. So you can clearly see that this is the case when the population standard deviation is given, and you know the formula to find the sample size. What was the formula? N is equal to how much? Z critical times over margin of error squared. Okay. But now, if you look at that formula carefully, do we have sigma given? Yes, sigma is given. Do you have margin of error? 4. Do you have Z critical? No. So first we want to find that Z critical. And you know, in order to find the Z critical, we draw that diagram. Let's do it. Draw the image. So this is the standard normal distribution, mean 0, standard deviation 1, Z along the x-axis, 0 there. And this one is 96% confidence level. So 96% area will be in the middle. So let's draw that 96% area in the middle. Okay, 96% area in the middle. 0.96. If 96% area is in the middle, how much is the remaining area? 4% divided into 2 parts, so 2% each, 0.02, 0.02. And the value that goes here in the x-axis is your Z critical. So Z critical is inverse normal. You know this already. Inverse normal. Then we need the area to the left. Look at the screen. We need the area to the left of Z critical. Area on the right is 2%. That means area on the left is 98%, right? 96% in the middle and 2% there. That makes 98% or 0.98. 0.98. Mean is 0, standard deviation is 1. Now, quickly use your calculator and tell me what is Z critical. Say that again, 2 point. Okay, 2.0537. That's correct. That's your Z critical. So we don't have that Z critical, but we got it now. Now we can plug into the formula for N and get that sample size. So this will be equal to, we plug in the value, Z critical 2.0537 multiplied to standard deviation 25, margin of error 4, and we have to square all this. And we'll get 164. Make sure you check it, 164.7533. Okay, 164.7533. And I told you, sample size, if you get the sample size as decimal, we have to round it up, right? 164 point something means 165. So if you want to do that estimation of age in that community, you must select 165 individual, 165. That is your sample size. Any question on this one? Okay, if you have no question on this, we are done with the first part of the confidence interval. We have two parts remaining for our next class. Okay, that's all for now.